everyone, and welcome to Chem class. This is my son's dinosaur, and it, as you can tell, it makes some kind of sound. It did sound a little bit better a couple of weeks ago, and it can walk along surfaces, but the dinosaur's starting to slur his words. The battery is going dead, so I did come along with some brand new ones to replace them, but it's a slightly annoying toy. I'm not actually sure that I want to do that. But let's use this as a conversation in our discussion between galvanic cells and fuel cells. So when we look at the battery that I should be replacing with, it's a discrete little packaging. It's a galvanic cell. This is what we call a AAA. It's a primary cell because they're not rechargeable ones, these particular ones. But what we have is stored in this little unit. We have the chemicals that will spontaneously react. Those chemicals will convert their chemical energy into electrical energy. And the thing about these is that the chemicals will all get used up. So it's all one-way direction of that chemical energy into electrical energy. You use up all the chemical energy and then the battery goes dead. We chuck them in landfill and we replace them with a new one. So the thing about these is, as I said, it's a discrete packaging where everything that's there is all that's available, and then it's done. How is that different from a fuel cell though? Well, a fuel cell is still a galvanic cell. So like you've discussed in class and probably looked at diagrams, there's still going to be a cathode and an anode and electrolytes, and there's going to be particular chemicals that go in, and we'll have an overall equation for this spontaneous reaction. All of that still stays the same. Charges on the electrodes still stay the same. But a fuel cell, think about it this way, is being constantly fueled with those reactants. So instead of being a discrete little packaging, what you have is a system where it has almost like tubes inputting into that system that constantly feed the reactants. And so the difference is, in our dinosaur, we can hear that the battery is starting to run down as he starts to slow down and slows down his walking and the noises that he makes. But in a fuel cell, because it's a constant supply of reactants, it means that there's no slowing down. It is a constant output of electrical energy that doesn't run down as long as the reactants are still being fed into the system. So it's slightly different. The thing about fuel cells as well that can be a slight difference from our normal galvanic cell setup is that often those fuels that are going in are actually in a gaseous state. So it makes it a little bit trickier to get contact between those reactants and the electrolyte. So we tend to have electrodes that are porous and often coated with a catalyst to maximize that particular contact and transfer that we need. That, of course, adds to the cost of the fuel cell, which is another comparison you might find to these cheap galvanic cells. Hope that helps.